All right, guys, so you should have already watched the first video that was all about the Pythagorean theorem. And this video is going to finish up this foldable. All right, so we're first going to go over what we call the triangle inequality theorem. Okay, triangle inequality theorem. And it basically tells us when we have a triangle and when we don't. Okay, so in order to have a triangle, okay, I'm going to put in order for 3 side lengths that's a T, to form a triangle. This isn't a right triangle, just a triangle. The 2 smaller sides must sum, so when you add them, to more than the biggest side. Okay, so in other words, the 2 smaller sides. Now when we do this, our A and our B are always going to be our 2 smaller sides. Okay, so I'm going to put purple denotes 2 smaller sides. And then our C is going to be our largest of the 3 sides. And I'm going to go ahead and, I don't know, highlight it. Let's go yellow. Okay. And it does say here C is the largest side. So in order for this to happen, when we add A and B, it must be greater than C. All right, so let's do a few examples. Now I'm going to first go through and I'm going to highlight our biggest number in each of these with yellow. Okay, so our yellow is going to be our C. So 20 is our C. And a lot of times these will be written in numerical order, but not always. So like these 3 are, this one is, but when you get down to here, clearly it's not. So 11 would be our biggest number and 14 will be our biggest number. Okay, and then I'm going to highlight the other 2 numbers, or our 2 smaller numbers, with purple. I encourage you to highlight as well. Okay, now all we need to do is we need to check to see if the 2 smaller numbers, if 5 plus 6 is greater than our biggest number. Well, in this case, 5 plus 6 is 11. 11 is bigger than 7. So then yes. Okay, these 3 lines form a triangle. So you can physically form a triangle with side lengths of 5, 6, and 7. Okay, now B, we want to know, do the 2 smaller sides, so is 10 plus 10 greater than our biggest side, which is 20? Well, 10 plus 10 is 20. Is 20 greater than 20? No, 20 is equal to 20, not greater than 20. So no, if we had these 3 side lengths, we could not form a triangle out of it. Okay, let's do one more. So, are the 2 smaller sides, so 5 plus 12, is that greater than 13? 5 plus 12 is 17. 17 is in fact bigger than 13. So yes, these 3 would form these 3 could be side lengths of a triangle. All right, I want you to go ahead and do D, E, and F on your own. And all you need to do is say yes or no whether or not it forms a triangle. All right, so as you can see on D, I added up the 2 smaller sides, and 14 is in fact bigger than 11. So yes, these form a triangle. On E, my 9 plus 1 is 10. 10 is not bigger than 11. So these would not form a triangle. And then on F, my 5 and 7 added together gives me 12. 12 is not bigger than 14. So that would be a big fat no. All right, so let's go ahead and look at, if we know that it forms a triangle, how do we know if it's right, acute, or obtuse? Okay, so we should already know that if a squared plus b squared equals c squared, we have a right triangle, okay? And remember, on all of these, my c is referring to the longest side. Okay, the longest of the three sides. All right, well, if a squared plus b squared is greater than c squared, we have an acute triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. Okay, so let's do some examples here. All right, so let's look at A and B. Now I'm going to highlight my biggest side yellow. And I'm going to highlight the two smaller sides, purple. Okay. Now, it says determine if the given side lengths would form an acute, right, or obtuse triangle. So it's telling us they do form a triangle. So what I want to do is I want to find a squared plus b squared, and then I want to compare it to my c squared. Okay, so a squared plus b squared would be 23 squared plus 18 squared, and my c squared would be 25.2 squared. Okay, now I'm just going to put this into my calculator. Okay, 23 squared plus 18 squared, that gives me 853. 25.2 squared gives me 625. Okay, well, 625 is smaller than 853, or you can say 853 is greater than 625. So my a squared plus b squared is greater than c squared. Okay, so if I go back to my rules, a squared plus b squared is greater than c squared. It's right here. That tells me I have an acute triangle. So all I would have to write here is acute. Okay, let's do another example. All right, so once again, my a squared plus b squared, and I want to compare that to my c squared. Okay, a squared and b squared are in purple, so 20 squared plus 37.5 squared. And I want to compare that to 42.5 squared. If I just put this in my calculator, guys, I get 1806.25. And if I put this into my calculator, I get 1806.25. So these are equals. So I can say my a squared plus my b squared is going to equal my c squared. And if we go back here, when they are equal, we have a right triangle. Okay, so this would be right. All right, so I want you to go ahead and do these on your own. I'm going to help you a little bit. So I'm going to highlight my biggest one, yellow. And then I'm going to highlight my smallest two, purple. Okay, now I want you to go through, find your a squared plus b squared, and then find your c squared, and then compare them. And then after that, use this chart right here to figure out if it's acute, obtuse, or right. So go ahead and do C and D on your own. All right, so on C, when I do 16 squared plus 24 squared, I get 832. And then when I do 27 squared, I get 729. So my a squared plus b squared is bigger than 729, and therefore I have an acute triangle. And on D, my a squared plus b squared is 4 squared plus 13 squared. I put that in my calculator, I get 185. And then my c squared is 225. And my a squared and my b squared, therefore, is less than my c squared. So if I go back and I look at this chart here, that tells me it is obtuse. So part D is obtuse.